This last presentation on the various types of simple statistics is about the standard error of measure. The standard error of measure talks about how much variability there is in a test score. Do you remember last week when we talked about trait and method error? One lies with the person and the other lies with the environment. Error is why a true score may not be the same as the observed score. Things impact the student taking the test. There is no perfect test situation. Therefore, there will always be a slight variability. That's the standard error of measure. This slide shows the calculation for a standard error of measure. While you will not have to calculate standard error of measure, you will see standard error of measure on test results, so you need to know what it means. The SEM, or standard error of measure, is a measure of internal consistency. If you recall, this is a type of reliability. For example, on the measures of academic progress, or MAP test, a typical standard error of measure is 2.9 to 3.1. So why wouldn't it be lower? Why isn't it higher? And what does it mean if it is higher than that? Let's take a look at an example. On a MAP test, a student's RIT score, remember RIT's just name of the standard score on the MAP test, is 211 with a standard error of measure of 2.9. Their true score would be between 208.1 and 213.9. That's 211 plus and minus 2.9. If the standard error of measure would be 0, then the raw score equals the true score, or the observed score equals the true score. But we're dealing with children and adults, various environments, and so there is always a little bit of error in a test result. What we need to look at is if it's large or if it's small. A smaller standard error of measure is always better because it shows greater consistency. The smaller the SEM, the more reliable the test. Our goal is to minimize the standard error of measure. In other words, we need to minimize the trait and method error in a testing situation. So bottom line, we also can control part of the standard error of measure. Let's look at a visual representation. The test results show the observed score. In this case, we're using 125 as the observed score. And the shaded bar shows the standard error of measure. On test results, the standard error of measure can be shown in a variety of ways. For example, as above, or it could be the case on MAP testing you will often see where the observed score is bolded and in the center, and the plus or minus the standard error of measure are next to, on either side of the observed score. Or it could be 125 plus or minus 3. Or it could be a diamond represents the score and a single line represents the standard error of measure. You will see all of these variations on different tests. The standard error of measure is closely related to another construct we call the confidence interval. The confidence interval indicates that there is a 95% probability that the student's score will fall along a certain band. The confidence interval is calculated by multiplying the standard error of measure by 1.96. So if the standard error of measure is 1, then the confidence interval is 1 times 1.196. Therefore, the confidence interval is 1.196. So there's a in this case with a score of 90, there's a 95% probability that the student's true score is between 88.04 and 91.96. As you can see, they're similar constructs. In each case we observed so far, the standard error measure and or the confidence interval was equidistant from the observed score. In the case of the MAP scores, it was 125 plus or minus 3 or 2.9. But as you prepare to complete your assignment, understand that this may not always be the case. The standard error of measure and the confidence interval is based on the student's performance on the assessment. So consider the observed score an average of all of the responses the student gave. The length and distance of the SEM or the confidence interval from the observed score provides insights to the test and the student's performance on the test. Let's look at some examples. In this first example, the variance of the standard error of measure is equidistant from the observed score. This is fairly common in an adaptive test like MAP testing because the test adjusts question difficulty based on the student's response. Therefore, as the student answers and gets items correct or misses items, the test adjusts. Therefore, the variance, the standard error of measure, tends to be equidistant. In the second example, variance is equidistant from observed scores, but is much longer in length. This can be a result of increased trait or method error. The student likely answered some very easy questions wrong, but also got some very difficult questions correct. Therefore, the error is much broader. In this third example, the variance is not equidistant from the observed score. This could be a result of the student answering some very difficult questions correctly. In general, they had a body of knowledge that they scored relatively the same on, but it could be, for example, on a math test, is that they're very good in one area, algebra or measurement, have interest in that or have had some extra experience. Therefore, they could have gotten some very difficult questions correct, but not overall. In the last example, the longer part of the line is below the observed score. This could be a result of the student missing some very easy questions compared to their average answers. It could be careless errors, or it could be the case of like an ELL student where they have a strong knowledge of certain core subject, but they may have lacked some vocabulary or background knowledge and were not able to answer some easier questions.